Screencast 10.1. In this one I'll be trying to model the motion of a rigid object for both fixed axis and free axis of rotation. For my fixed axis of rotation, my model looks like this. The three different sphere objects are connected by three massless cylinders, and the this triangular shaped object would be rotating in clockwise direction with this point as the center. So here's my model. This three object defines the three spheres at the end of triangular, at the vertex of triangle, and these three are the cylinders that connects those spheres. And this is the main program that updates the angle theta. And here is the update of position. Okay, let me run this and I'll show you. Okay, oh, it's an anti-clockwise rotation. Okay, this is the center of the this is the center at which the object is rotating, and that's it. That's the free axis rotation, and L is in the same direction as omega, so it's free axis rotation. Sorry, this is fixed axis rotation because L is in the same direction as omega. And I'll show the derivation of free axis rotation. Okay, here it is. In this case I have considered a prism in this case, in which the masses are at the triangular ends and they are connected by the massless cylinders. So I have supposed the omega to be in x and y direction, but in z direction it's 0. My z direction is this is my x direction, and that is my y direction. So first I need to find the moment of inertia tensor, and since it is a free axis rotation I'll have to find the tensor. In this case Ixx is given by sum of all the mass elements plus y square plus z square, and then I have to sum up for all individual masses with their y and z component squared, and then that comes out to be this relation. Okay, once before I go into that, the distance from one mass to another mass in this triangular position is a, and the distance from this triangle face to that triangle face is b. That's my supposition, and that's how. Okay, here's my Ixx using this formula, and similarly my Ixy is negative sum of all Riemann sum of m alpha xy. So if I sum over all elements, then I'll be getting minus m a square root 3 over 2. Similarly Ixz is given by negative Riemann sum of m alpha xz, so this is 3mab over 2. Using the same formulas for Iyx, it's gonna be negative Riemann sum of m alpha yx. I get this, and Iyy would be Riemann sum of m alpha x squared plus g squared, and then using that I get this. Similarly Iyz would be this, and Izy is this, and Izy is this, and Izz would be this. Putting all that together I get the inertia tensor Ixx, Ixy, Ixz, Iyx, Iyy, Iyz. Similarly Izx, Izy, Izz. And then my my angular momentum is given by inertia tensor dot omega. So here's the matrix multiplication. So this component multiplies with 1 plus this component with another 1 plus this component with 0. So similarly, after I go through all the matrix multiplication, this is what I finally get. And as you can see, my angular momentum is in all x, y, and z direction, whereas my initial angular velocity was only in x and y direction. Even from that means the angular velocity and angular velocity and angular momentum are not in the same direction in this case, which is why this is also called as the fixed axis rotation. And that's it. Thank you.